Hi guys, today we'll be looking at vectors and specifically using column notation. So this is what I would consider an easier part of vectors. So we're going to go straight into exam questions and I'll use those to describe what we need to do. So often we get asked to find something like that, a plus b. So we are given, let me use a different color actually. A is the vector 2, 3, and B is the vector 1, 5. So firstly, what this means is A goes 2 across and 3 up. So vector notation is always in the form x and y, x and y. So when we're adding vectors, we simply have 2, 3 plus 1, 5. So we have to just add the respective x components and y components. So we end up with 3, 8. So if we combine A and B, we have a vector that moves across 3 and up 8. So remember, this notation is supposed to be designed by us to make life easy for ourselves. So if we want 2 lots of 2, 3, we literally just got 2 times 2 and 2 times 3. So it will be 4, 6. And if we look at 3b, so 3b will equal 3 times 1, 5. So that would be 3 times 1 and 3 times 5. So we get 3 and 15. So we now have to add these two together. So 2a plus 3b is equal to 4, 6 plus 3, 15. So we add the x's together and we add the y's together. So we end up with the vector 7, 21. So let's have a look at another one. Here we go. So, very similar question. Pause the video here and give it a go. Welcome back. So, we have A plus B. 4, 1 plus 3, 2 is 4 plus 3 and 1 plus 2. So we're going to get the vector 7, 3. And 2a is that minus b, which is that, will equal 8 and 2 minus 3 minus 2. So we'll get the vector 5, 0. So in other words, we have a movement that goes across 5 and it has no vertical component. What have I got next? I think this is the last one of this type. So let's have a look at this one. We have A plus B again. So we have A equals minus 2, 3. And B is 5 minus 1. So the vector A plus B equals minus 2 plus 5 and 3 minus or plus minus 1, which is 3, 2. So this one would be 3, 2. And then part B, or part 2 of A, is 2A minus B. So first we need the vector 2A, which is 2 times minus 2, 3, which is minus 4, 6. Therefore, 2A minus B is minus 4, 6. Take away B. So we have minus 5 and minus 1. So you can see where they tried to get us there with the double negative. So the answer to that is minus 9, 7. And the final part of this video is dealing with bits like this. So what this means, let me explain the notation first. This means if we imagine we have 2 points, A and B, we're interested in how we get there. So the distance between the points, essentially. Yeah, so it's the movement. Yeah, so we have to do for AB, the vector AB, we need vector B take away vector A. So we need this point, and from it we'll subtract that one. So we're given that B is the point 4 minus 1, and we need to subtract from it the point A, which is 3, 2. So we will have 4 minus 3 and minus 1 minus 2, which gives us 1 minus 3. So the vector AB is 1, negative 3. And then if we look at part B, C, this time we're given C and D, and we want the vector CD. Finding CD. I think you can have a go at this. So, Siri, can you play the countdown theme tune, please? Hey, Siri. Play the countdown theme tune.
Now playing Down by Jay Sean on Apple Music.
Well, imagine the countdown theme tune played. And so hopefully you would have got CB is vector D minus C, which will be 2, 1 minus 5 minus 2. So we should get 2 take away 5 and 1 minus minus 2, which gives us negative 3, 3. Therefore, CD is negative 3, 3. Dun. And one more for love. So part A. Again, this is a good point to pause the video and give it a go. But part A, we need to find AB. So vector AB is B take away A. So in this case, that is 4, negative 3 take away 5 minus 1. And that gives us 4 minus 5 and minus 3 minus 1, which is -1, -2. So AB is -1, -2. And let's give part B a go. Well, so if we give part B a go, we have, again, it's CD. Finding vector CD, that will be D take away C. So we have -3, 9, -1, 6, which is -3 minus 1 and 9 minus 6. So therefore CD is -4, 3. So that is column notation and column vectors. I hope you enjoyed the video. See you guys soon. In the next video, we'll be looking at vector proofs.